Okay, taking a look at this problem, we're going to follow these steps: given, implied, freebies, and kind of talk it through. Given, implied, freebie, talk it through. Given, we're just going to mark what's given on the diagram, and it is given that x, y, z is isosceles, and here it clarifies which sides are congruent, so that's x to y is congruent in y to z. So there we go. You were also told that A is a midpoint of x to z. Okay, so that's done with our given. Check what's implied in this scenario is, of course, the midpoint implies that these two segments are equal. What's also implied is if you have two equal sides, you have two equal angles. Two equal sides, two equal angles. What's also implied by a corollary of medians in isosceles triangles, that a median inside from an isosceles triangle from its vertex, which y would qualify as the vertex, it creates both perpendicular to the base and it bisects. This here's bisects. You know that for sure. That is implied. And then what is very subtly applied and actually would qualify in my book as a freebie. Freebie is things that are true, even if they're not implied by the given. True, but not given. And the very subtle thing that you need to notice here that would be very easy to overlook is that this is sitting on an XY grid. Okay, this is labeled. This is the axis X, not the point X. And this is the axis Y. And because by their nature, they are vertical and horizontal, of course, this being completely vertical and this being completely horizontal, that indirectly implies that there's a right angle here because vertical and horizontal. Therefore, we're trying to prove that triangle YAZ is isosceles. And the only thing we need to prove that is one of two things. Either we need to prove that you have two equal sides, or we can indirectly show that we have two equal angles, which implies two equal sides. So let's just talk that through here. Because of that right angle here, and because of the XY axis, this implies this is a right angle. That forces these two angle measures to both be 45 and 45, which if there's a right angle here, forces this to be also 45 and this also to be 45. And there you go. If you have two equal angles right here, 45 and 45, then it forces these two sides to be equal and thus making it isosceles. Now, what that would look like in a proof, there's a variety of different ways. I personally like webs because we want to see how this all fits together. But the most common is a T-bar, so that's the one I'm going to do here. All right, statements is the traditional reasons. So number one, of course, triangle XYZ is isosceles. I'm just going to put everything in the middle A is the midpoint of XZ, and XY is congruent to YZ. All of that, of course, is given. Now, we've established that we have an isosceles triangle, but because of that midpoint, we officially need to say, number 2, that YA is a median. And the reason is, so YA is a median, and that would be definition of a median, which connects vertex to a midpoint. All right, now here's the key to that corollary. It's called the corollary of the isosceles triangle theorem, the median in an isosceles triangle. And you can see here that if you have a median from a vertex, it does two things. One, it bisects the vertex and it's perpendicular to the base. So because of establishing the fact that it's a median and establishing the fact that it's isosceles, then that we know we get this right angle here, and the vertex is being cut in half. We actually got 2 pieces of information, 3. So we know that angle XYA is congruent to angle ZYA, and angle YAX and angle YAZ is a right angle, because number 3, the median from the vertex of an isosceles triangle both bisects the vertex angle and perpendicular to the base. Okay, what does that do for us? Well, that is going to force, okay, we first have to establish, though, before we can pull out those 45s, is the fact that these are perpendicular and makes a right angle. So that's the trick to the whole problem. We have to say that segment XY is perpendicular to YZ. And so that's these guys right here. And that's because they are aligned with the X, Y, horizontal and vertical axis. So you know they're perpendicular, which implies the fact that number 5, there's actually a lot of steps here because you have to imply every single step, that the measure of angle XYZ equals 90. And that would be the definition of perpendicular lines. They make 90 degrees. All right. Now, I've already established that these 2 angles are congruent, right? So therefore, we know that they must equal 45 degrees. So the measure of angle XYA equals 45. And the measure of angle ZYA equals 45. And that's because that 90 degrees is bisected. And that's indirectly implied by step number 3 and step number 5 combined. Okay, so you got these two angles right here. We've established that that's a right angle. Therefore, angle, these angles, let me color code them out here. We need to first say that we got the 90 degrees right here. No, wait a minute. Yeah, because of the altitude, but we need to state those. Yes, we did state them right here. Okay, so we got those two right angles there. And because these are 45 right here, that implies fact that number 7, that this angle YXA, measure of angle YXA equals 45, and the measure of angle YZA 45. And we get that because triangle sum 180. And we already established that this angle's 45, that's 90, therefore that's 45. Step 8, look right here. We're going for, let's get really, really close. We have established now, let me just erase all of this. We have now established that this angle is 45 degrees. Okay. ZYA. We've now established this YZA is 45. So ZYA, let me color code that. ZYA is right here. I call that the green. ZYA. Or YAZ is, oops, go back. Okay, so ZYA is 45. That's going to be ZYA is 45 right here. ZYA, that's the blue. And then YZA is 45. We established that here. That's the green. So now we need to say those are congruent. Angle ZYA is congruent to angle YZA. That's the definition. Whoops, I lost track. That's 7. That's 8. That is the definition of congruent angles. And that's because they're both 45. Last but not least, since we have two congruent angles, we have two congruent sides. So now we can say that triangle, how do they phrase it? YAZ, yes. YAZ is isosceles, and that's because when you have two congruent angles, it implies that you have two congruent sides. That is called the converse isosceles triangle theorem.